So glad to be here. Very happy to get an opportunity to learn about this community and what you guys have been doing with SU2, or that code is being developed, the directions that it's taking, and how the community is picking it up. So quite exciting stuff. And what I'll do is give you a very quick intro to what we do on our end. So we are a CFD post-processing company. And yeah, I'll just go over that quickly. Start by just, I think a good way to explain what we're about is to say a few words about our customers, who's using our products. It's at the same time, it's quite hard to do because we have thousands of customers, dozens of thousands of users around the world. So I just picked a few that I thought will be relevant to this community here. We have a lot of them in the aerospace, defense industry, turbo machinery as well. So you'll recognize a lot of these names. And I think a good way to summarize the reason why people use our software is that they like to have easy, powerful software. I could put it the other way around as well. We have powerful yet easy to use software. And we try to provide great support. And I'll come back to that at the end of the talk. So some of you may not be familiar with the fact that we have two post-processors now. We're under the same roof, Tecplot that we call 360 mostly now, and FieldView. We've been under the same ownership for 5 years now, and we merged the two companies. So that allows us to leverage more development resources going forward. And so you might be wondering then, why pick one or the other? And I'm going to say actually that a lot of the customers that I've shown in the previous slide have both software in-house. And, if I try to summarize it, I think 360 is more well known for the quality of its 2D and XY plots. You can have very nice annotations. It supports LaTeX in its annotations. You can export your plots to raster or vector formats. So for academic publications, it's really high quality. And it also has a very nice Tecplot, Python interface that we call Tecplot. Very capable, full feature. And on the other end, FieldView has a number of advantages. For instance, it has native client-server architecture. You can run it in parallel. We have hybrid parallelization and very high-quality graphics. So when I say easy and powerful, I mean things like that. If I show quickly. So to start with our client-server architecture, let's do very powerful things. So you could be running on the laptop over here, connecting through the network to a cluster, say at your university. FieldView automatically supports a job scheduler. It's going to launch a job by itself, get the allocation of the nodes, start the servers on the nodes, and connect back to the client through firewalls and all of that. And once you have it properly configured, it's really done at the click of a button. So that's what we mean by power and ease of use. And if I show you an example in the FieldView itself, hoping that the video is going to work, yeah. For doing local parallel now, I just have to go from local serial, and I hit the button, local parallel, and that's it. From that point on, FieldView knows to use all the cores on my machine. We're using a mix of MPI and multi-threading. And you can see when I load my grid over here, I'm at 100% CPU. I didn't have to tell it how many CPUs to use. It's just grabbing everything and using it. So very easy to use. And that gives us great performance. So here, in the second stage, we are loading the results because this is a segregated format that we are loading. And in minutes, you'll see that we have the data in the session, and now we can interact with it. We don't have to worry anymore about the fact that it's parallel or local or client server. It's always the same from that point of view. And just going ahead and creating a boundary surface. So I'm showing you the wing profile that has been simulated over here. And you'll see when I start showing some results. So I'm using we have an option to filter the list of variables. So I'm showing coefficient of pressure on that wing profile. And yeah, if I switch to a better color map, you'll see that it's a very fine simulation, 400 million cells, 400 million that I'm post-processing on the laptop over here. Yeah, it's a bit hard to tell with the dim light, but I have some flow separation happening, and you can see that I'm interacting with the data at full speed over here on the laptop. Just to give you an example of how people use FieldView, then we are creating a cut plane. You can adjust the location, the direction of the plane very easily. You can fine-tune the location or enter the location directly. And in the same way, then showing scalars on that plane. And you can see that we have a lot of physics being shown over here. And again, we are able to interact with this data at real speed on a very small system. So that's what we mean by power and ease of use. Then FieldView also has capabilities for doing very nice graphics. We call that realistic materials. But the way we do it is that we don't want you to have to adjust all the settings for PBR. You don't need to know whether it's a dielectric or a metallic material, what roughness level you have, what color. What we do is that we provide the materials for you. So you go ahead to click material, you go to the left materials tab, and then you have all the materials set over here directly for you. And you can see that the effect is really, really good. And again, all that interactive speed, we prefer not to use ray tracing for that. You will need a really good graphic card and slow rendering. So we have other methods for doing realistic rendering at interactive speed. And that lets our customers, if they need to communicate on their results, make simple animations like that looks very real, although we are just using a few tricks for doing the rendering. For getting your results from SU2 into our software, it's quite simple. So I just stole this page from the SU2 documentation on your Git repo. So if you've been using the volume or surface export to ParaView, the VTM export, both 360 and FieldView read that. So that's easy. But now if you want to go to, say, 360 and give it a shot, we strongly recommend that you try the binary Tecplot export, which is using the CISL format, and it's valid both for volume and surface exports. So let me tell you why you should be using that one instead. So here we're doing a comparison of reading in that table at the bottom a VTM file or a CISL file for the same case. And we are doing comparison with ParaView. So, I don't mean anything bad about ParaView. It's a great tool, very clickable, but it's not did specifically put a CFD post-processor. And of course, it doesn't have all the optimizations that we can put in it. So if you compare the performance just for reading the VTM file first between ParaView and Tecplot 360, Tecplot 360, you can tell is a lot faster for reading that data set. And then if you shift to the CISL format that we recommend, you can see that the time goes down to 20 seconds for just the same case. So basically what we are doing here, the trick, as you can tell, is that we have a bit more stuff in the file. So we are putting more data in it so that we can navigate through that file very quickly and just read the information that we need for doing exactly what you're doing at that time. So that's how we get the optimizations here. The great thing is that that CISL export, it is based on the libraries that we provide. So we do the work of maintaining that library. The SU2 community doesn't have to do it for us. And you just update the libraries that are called Tech.io. And Tech.io is ready today for high order elements. So as you guys will be moving on to using high order elements more in SU2, Tech.io already has support for that. After last year's conference, I believe we worked with Edwin to try that. And he confirmed that Tech.io with support for each high order elements is working in an SU2 branch. So I don't think that work made it to the mainline yet, but it's been confirmed that it was working by Edwin. And for more details on high order elements in Tecplot 360 and in the CISL format, I point you to a presentation that my colleague Antoine gave at the conference last year. It's still available on the conference website. And going back to Tecplot 360, note that I've already said a word about FieldView, mentioned that it has a great Python API that is called PyTecplot, and it lets you do some really nice things. For instance, you can automate your post-processing, make all of your images or videos in batch. We also have a script that is really nice for accelerating the generation of a transient video like this one. It's going to automatically do parallelization over time. So each Tecplot batch process is going to take a portion of the time steps, and they're going to run concurrently so that you get your video faster. So all of that can be handled by a Python script that we provide. You can also do further analysis of your data. It's great for doing quantitative analysis. Like here, we're chopping down the data set and looking at it from the scalar concentration point of view, so putting it down into buckets to feed the histogram over here that is evolving over time. So some idea of the quantity of analysis that you can run. And you can also do some nice customizations if you're into Qt coding. PyQt is available. You can create your own panel. So I mentioned very nice 2D and XY plots in Tecplot. And here the idea is that the few settings that are going to be used all the time by this researcher are captured in this simpler GUI. And then it's just changing the input data and the X and Y variables and customizing the two plots very easily. And as I mentioned, this can go out into a vector export for great quality into your publication. So if you want to learn PyTecplot, we have a full repo with, I think, about 70 scripts available that we keep adding to. So that's a great way to learn through some examples on what can be done with PyTecplot. One last word about our roadmap. I imagine that some of you already tried Tecplot 360 in the past. Maybe you tried FieldView as well. Now will be a really good time to give it another shot. We have a beta version that is out that we call Tecplot 360 MB beta. That's for more better. I don't know why that made sense for my colleagues in the US. The idea with it is that they've fully re-engineered the way Tecplot 360 works with your unsteady data, particularly. So much faster to go through various time steps. And it lets you do some very advanced things like a time history plot, like this one, with no scripting at all. So very nice. And we see our community starting to adapt this beta version and providing feedback. And another new thing that is coming up is a fully re-engineered graphic engine. So I mentioned the advanced graphics that we have in FieldView. The idea is to go one step further and use the same engine for all of our products. So we get the same great performance. The main thing with it is that we wanted to move away from OpenGL, particularly if you're running on a Mac. OpenGL is being deprecated. Apple is pushing everyone to Metal. So the strategy we're going toward is to move on to Vulkan. And Vulkan is a new graphics API from the Kronos group. It has great performance. It gives you a lot of power in terms of managing the GPU. And it's going to get us great performance. So first example here, we are overloading the card with repeating the same geometry many times. So we have a lot of triangles to push to the card. And so in blue, we have the previous Tecplot 360 version. In orange, we got the new engine. And so the faster is better, obviously, for pushing data to the card. And we are getting about a 5x speed up. Because at the time it will take you to get the first image. Press the button, you want to see that's your face. It takes 5 times faster to get to the card. And the second speed up you will get is with the frame rate. Once you have that image, you want to interact with your data in a very fluid way. So for comparison here, I'm showing the previous FieldView version on the left, loading the same case that I was showing earlier for the parallel demonstration. And just to show you that, so that was shot on my laptop, very standard laptop with a standard GPU. And you can tell that I'm kind of pushing it. Now I have a very large ISO surface. So the case is 400 million cells. And with a nice surface of Criterion, I can go up to 70 million faces just for the ISO. And you can tell that, yeah, it started to be a bit too slow for my system, about 4 frames per second. And going to the new engine, now it's full interactive speed again. I'll zoom in on the surface and you'll see how detailed it is. So very nice physics over here. And we're getting 21 FPS, again, just on the laptop. If you had a bigger workstation with a good graphic card, even a gaming graphic card, that will give you even better performance. So again, about a 5x speed up. We're very excited about this new engine. And it will be coming out first in new beta sometime around the end of the year. We're shooting for early December for providing new betas for both products. And then our first production versions in 2025, you will be using this new engine. And one last word about technical support. I mentioned it at the beginning, explaining why our customers choose us. Again, for that, don't trust me, trust our customers. These are a few quotes that we are getting. Every time we close a support thread, we send a survey to our customer, and they tell us how we did. And so we get very good rating from our customers. These are the ones who reply. And the great news is that for all of you who are working in academia, you'll be getting the same support from us, the same team. We're not pushing academic customers to a forum. You go through the same loop and the same people answer your questions. And for academic customers, we provide a very nice package. We have a suite that has all of our tools for a flat price. So you get Tecplot 360 and FieldView. You don't need to choose. And we also provide Tecplot Chorus, which is this tool over here based on Tecplot 360, but with a totally different interface. And it lets you navigate through a lot of cases. So if you're doing UQ or verification validation, that's great for looking at a lot of runs. And again, our academic suite has full technical support. So with that, if you want to get started, all you have to do is go to our website. At the top, we have a link to the free trial, and that lets you download Tecplot 360 and FieldView and try it for yourself with a free evaluation. So that's all I have for you today. Not sure what I'm doing on time. Yeah, I'm happy to take questions.
Thanks for the time. Yeah, okay.
Nope.
Out of curiosity, I've been using Tecplot when I was a PhD student and for last.
So last month.
Unfortunately, I don't get to use it anymore. But I was curious, where is your company based and how many people work in it?
Yeah, we have about 50 employees, mostly based in Seattle. That's where Tecplot is from. And the FieldView team is from New Jersey. So
mostly 50. And so, how many work in customer support?
Yeah, we don't go that much into the details, but we have a good crew, and so we have a couple of guys shared between the East and West Coast, and we're starting to have staff in Europe as well. Plus we have Lothar is actually from our German office, so I guess I wasn't counting you in the 50. So we have local support from Germany, so in your time zone for all European users.
Thank you.
Any other question? Yeah, Tobias?
Yeah, Tecplot Chorus, I guess it's more integrated with the 360 and with Field.
Yeah, so it's actually a whole other software. It's using Tecplot 360 in the background for generating the images, but you can't even tell. You actually started from something different. Yeah, and it's more, yeah, it is the same technology as 360. Yeah. Thank you. One question.
I think with the time, I actually have a question too. I don't know how much you can say. So the sizzle format, subzone load, right?
Yep.
So you're accessing different parts of the domain.
Yep.
Is FieldView doing something similar? How do you guys think about that in FieldView volume data?
So FieldView has a similar technology, but the way FieldView uses it is you actually have to load the full case once, and you'll be writing an equivalent to the sizzle format. But at that time you will be writing it to file and reusing it for any following times that you'll be loading that data set. So we haven't pushed the synergy yet. We are doing mutual work on some readers, like BTK, for instance. We're using the same library. And that new graphics project is the first time we're leveraging both teams applying the same technology. But yeah, it's not that integrated yet with FieldView being capable of loading the SQL format. Yeah.
Okay, we should probably stop there. Let's make our speaker again.
Thank you.